to move in water. So in addition to the support structure, we'll talk about other observable features that this fish has that enables it to move in water. So in my slides, I hope you're able to see the diagram of a bony fish. Now, the important structure that it has that enables it to move in water, I want you to look at the scales, and you can bear witness with me that they are overlapping backwards. And then there are fins there. Near the head, we have the pectoral fin. This side there is one, the other side there's another one. So those such fins are called paired fins. Then on the lower side, but in front, we have the pectoral fin. There's one that is seen, and there's another one on the other side. There are two. They are also paired fins. Pectoral and pelvic fins are paired. We have the dorsal fin on the upper side, and then we have the anal fins just behind the anus, or behind the vent. We have the caudal or tail fins. Now, so what do these features enable the fish do? If the fish wants a forward thrust, forward movement, it will move the caudal fin side to side together. So that forward movement is enhanced by the propulsion activity of the caudal fin, which is also called the tail fin. If the fish wants to balance in water, it will use the paired fins. The paired fins are the pelvic and the pectoral fins. If the fish wants to move up and to remain in its straight upright posture, the way it is right now, without rolling, without moving side by side to side, it will use the dorsal fin. The dorsal fin maintains the upright stature of the fish. If the fish wants to move fast movement, the fast movement is enhanced by the structure of the body. It has a streamlined body. So it's able to reduce friction as it moves in the water. It has scales that overlap backwards, and that one enables it to move faster, reducing friction. It has muscles called myotomes that are able to contract and relax, enhancing the forward thrust. These scales are covered by a layer of mucus, and that one contributes to reduction of friction as the fish moves in water. And the last, so there are 3 types of movements that can be exhibited by the fish as it moves in water. We have some, the yawing can occur, and yawing, we found out that it is the deflection of the head, and the head deflects because of the propulsive activity of the tail fin. We have looked in the previous slide. We have found out that forward movement in fish is enhanced by the propulsive activity of the caudal fin. So you will see, if you went to an aquarium, you will see fish moving, but the tail fin will be propelling from side by side, and that one forces the fish to move forward. That propulsive activity makes the head of the fish to change from, or to move from its permanent position, and that brings about yawing for the fish. And this yawing is prevented by the dorsal and the ventral fins. The pitching is that tendency of the head of the fish to plunge down, to point downwards as it moves in water. It occurs naturally like that. And pitching is prevented by the paired fins. We have the pelvic and the pectoral fins. We have rolling, and rolling is that ability of the fish to rotate around its longitudinal axis. You know what rolling is from the layman's language. That one is prevented by the dorsal fin. It maintains it. You have said before that it enables the fish to maintain it is upright stature, so posture. Those are the yawing, pitching, and rolling. Please make sure that you're able to acquaint yourself with these terms and then the various fins that prevent the fish from undertaking such kinds of movements. Before you left the class, I told you to describe how a finned fish, such as tilapia, moves in water. Before we, okay, I will not dwell on much on that. I'll talk about the adaptations of the fish, of the finned fish to movement in water. But before that, I will ask if there is any question. If there is any question. Yes, Brian.
Sir, I did not hear the fins that prevent pitching.
So I said that pitching is the tendency of the head of the fish to point downwards as the tail propels it forward. Sawa. The tail prevents it forward. And pitching is prevented by the paired fins that the fish has. Right together? If I want to take you back to the image, the fish has two types of paired fins. It has the pelvic fins and the pectoral fins. And so those ones prevent the fish from pitching. Right together? If they were not there, the fish will continuously move downwards. You know, it will plunge deep into the water. Are we okay?
Yes, thank you.
Yes.
Yes, we're okay.
We have said which features enhance fast movement of fish in water. There are so many features that enhance. We have talked about them before. I want to take you back. In this slide here, we've talked about forward movement. For the fish to move fast in water, the caudal fin propels it. So, but that force is also, its value is added by other mechanisms in the fish. Like, for example, the fish being streamlined reduces the force it uses to penetrate through the water. The scales of the fish overlapping backwards reduces friction in water. The aspect of having a layer of mucus covering the scales reduces friction as it moves in water. So the propulsion of the caudal fin, streamlinedness of fish, scales overlapping backwards, having a layer of mucus in water enables the fish to move on it. Having a layer of mucus on the surface of its body enables the fish to move faster in water. Are we okay? Brian Nyakundi.
Yes.
Brian Nyakundi. Sawa.
Yes.
So I want us to go to, we talk about functions of the various structures in fish. Talked about the pelvic and the pectoral fins. They enable the fish to change direction, change its level in water, go up or down. For braking, ikikimbia sana, it breaks. So that is the pelvic, the paired fins. They do those kinds of work, maintenance of balance in water, preventing pitching. And I think I've talked about that one before. We talk about the dorsal and the ventral fins. They prevent yawing. They prevent yawing. Ventral fins. Ventral is another name for the pelvic fins. Okay. So the dorsal and the pelvic fins, they prevent the fish from yawing. Okay. Sawa.
Yes.
Yes, we have the swim bladder. We'll talk about the swim bladder later. Swim bladder is some structure the fish has that is like your bladder, and it's able to keep air. So if the fish wants to rise to the upper parts of the water, it will take in a lot of air. And then that increases buoyancy. So the fish is able to move to the upper side, upper layers of the water, or it is able to float or to rise in the water. If it deflates swim bladder. I hope you understand that. So adaptations, another question you may be asked is, you describe the adaptations of the fish to locomotion in water. That's a very common question that you can easily get. So before we start now explaining how I come up with my points, I would like to get answers from you. What are some of the adaptations of finned fish to locomotion in water? Because a fish locomotes in its direction wholly. So what are some of the adaptations? Yes. Just a minute. Okay. So some of the adaptations, any hand? Nimrod.
Yes, the fish has strong tail muscles which contract and relax to bring about forward undulating movement.
Yes, the fish has muscles, strong muscles. They're called myotoms that contract and relax. And this ones enhances movement. Okay. Sawa.
Yes.
Nathan. Jonathan.
Its scales overlap backwards to reduce resistance to the flow of water and hence enhancing.
Okay,
movement.
the scales overlap and they are pointed backwards. Are you together? And so this allows water to pass over them without any resistance. Okay, that's how it's. Clifford Onyango.
The scales are coated with mucus to prevent friction as the fish moves through the water.
So the fish secretes mucus. It secretes mucus. It has mucus secreting cells. And this mucus overlies on the surface of the scales. So this reduces friction during movement. Any other point? Yes, Omutere.
They have a streamlined body which reduces friction between water and the fish.
Yes, they have a streamlined body that reduces resistance against water particles, and that one enhances movement in water. It enables the fish to move easily. Another point? So somebody is talking about a lateral line. Yes, it has a lateral line. What's the importance of the lateral line when it comes to movement in water?
The lateral line detects vibrations so that it may be able to sense predators and run away.
Yeah, so the lateral line enables to detect vibrations or changes in pressure in water, and that enables to respond appropriately. Get together, run away. Okay, yeah. So it has a lateral line that enables to detect vibrations and changes of pressure in water, and that one enables it to respond appropriately. Somebody else? Another point? I want to see people talking. Are those the only points that you guys remember? You have forgotten that a fish has fins. Fins. You talked about the paired fins and the fish fins that are not paired. And these fins play different roles in water. For example, the paired fins we have talked about, they maintain balance, braking, changing direction. So. And the unpaired fins, we have said that they prevent rolling, they prevent yawing. So you talk about the presence of the fins. They talk about it has the paired fins that now play the roles that I've said. It has the unpaired fins, like the dorsal and the tail fins and any anal fin. And those unpaired fins prevent the fish from yawing and rolling. So.
Yes.
Yeah, and what else can you talk about that? It has an inflexible head inflexible head that enables it to have a forward thrust in water. The body is laterally flattened, and this increases surface area, preventing it from rolling and yawing. Laterally flattened. So those are some of the adaptations of the fish. So let's see here. We've talked about a streamlined body, and that one reduces resistance. Levins, your hand is up.
Yeah, I'm asking, is it preventing it from pitching, or that helps it pitch? Yeah.
It prevents it from pitching. Levins,
Yes.
Just come up. I want you to define for us pitching so that we understand what you literally mean. What's pitching? Levins.
Pitching is the
Levins.
Hello there.
Yes, madam, you are in.
Hello, Manu.
Yes, madam. Ndiho.
I'm in finally. Now, I just wanted to interject a bit.
Okay.
There's that person who was talking about pitching.
Yes.
Remember, all those are what we call instabilities in water.
Yes.
It's like you're grounded on the floor, you cannot fall. But
Yes.
imagine an animal flying in the air or an animal in water.
Yes.
It gives way. So there's those instability of either falling the head down
Yes.
or moving sideways. They are called instability. So we cannot say there is adaptation for pitching. We are trying to solve the pitching, which Mwalimu anasema define. So how does the fish overcome the tendency of moving downwards instead of going on a straight course, or moving sideways, or rolling on its side?
Okay. Thank you,
so
madam.
It's good. They should define each instability and which fins helps them to overcome. Yes.
Okay. Thank you, madam. That's a very nice input. Categorically, it is an instability, and we're trying to prevent an instability. That's why I was asking Levins to define pitching, and then if you define pitching, then you will be able to understand the reason why I've said that it is to prevent that instability. So, Levins, can you define for us pitching?
Pitching is the tendency of the head of a fish to plunge downwards.
Tendency of a fish to plunge downwards. Now, is it okay for a fish to plunge downwards?
Oh, no.
No, you know, see the same movements. Levins, I want you to go and also observe, do some study on airplanes. So, what can happen, Levins, if an airplane or an aeroplane pitches downwards?
It would crash. It would fall down.
So if a fish pitches downwards, it will go to the floor of the sea. So it is preventing. So what's up?
Okay.
Prevent. So they prevent. Are we okay now?
Yes, thank you.
So, Madam Ndiho, we are talking about the adaptation of the bony fish to locomotion. So we have talked about we have talked about inflexible head.
I don't know how far you have gone, but it's okay. I'll catch up.
So we're just talking about the adaptations. So maybe you can also talk about them a bit as we move forward. So you can just talk about the adaptations and the locomotion in fish, madam.
Okay. Now I'm not very sure. Okay, it's like I like approaching this like an essay. If you look at an adaptation of fish in its habitat, let's start from there. Now, the question which you can be asked is either about the locomotion or just adaptation in general. So if we can talk in general first, because there's something to do with the fins, the gills, all that, you think about the functioning of the fish. One, it must locomote. So you think of which body part contributes to its locomotion. Then you can think of gaseous exchange. Which part or which structures are involved here? We have the gills, the operculum, the mouth, because you know about the inhalation. Then you can think about sensitivity in water. Does it use the eyes? What other structures does it use? And by the way, it has eyes. Does it see in water? Okay, then what is the role of lateral line? Because it's still under sensitivity. You talk about that. What about feeding? You know, you break down your discussion, if it's a messy, a general one, based on all the functions of the fish. And then now under each of the functions, you talk about the structures. I think for this topic, because it supports, we tend to ignore a bit of the gills because even the scales are to do the protection, but we cannot ignore sensitivity because it has to sense, you know, how does it detect which way to turn or to get away from, you know, something oncoming or something not in front. We cannot then ignore the fins or the paired and unpaired fins. And so this is where now you require that diagram, and I do hope they have their books. You must know to describe the fish itself. Why the streamlined body? What is a streamlined body? Okay, it's one that is like pointed on both ends, the head and the tail. Okay, a good example is the airplane, like the Mwalimu was using. Why is it tapered? That is just to reduce resistance to movement. You can imagine if the fish was so, the head was not as pointed, it was something blunt, it would use a lot of force to push through the water. Okay, so whenever now, because we want to approach this like you are writing an essay. If you're writing an essay, remember adaptation has to do with what? With the structure. You describe that structure and its contribution to the movement. And so you say it is streamlined. Don't assume that we know what streamlined is. Say what is streamlined. It is tapering on both ends, all right, to cut through the water with ease, or with less resistance. Then talk about the lateral line. Does it have a role in locomotion? Yes, it does. What is a lateral line? What is it made up of? Is it just a line that you can draw? No, actually it's a tube filled with some fluid, and it is sensitive to, is it the pressure? I think the pressure. So it is able to tell the distance, the whatever. So it is used for sensitivity. Enables it to turn either to the left or to the right. Then you look at the overlapping. I heard something about the scales. Yeah, the overlap. Yes, they have a role in locomotion. Reason, they overlap, face backwards, and they are covered with some mucus to reduce the resistance. And of course, when you talk about the mucus, the structure here we talk about, they have secretory cells that secrete the mucus. Talk about what is the role of the mucus. That again reduces friction. Yeah, I can see the diagram. They are very nice. So all these fins, do we know them? Which are the paired ones? Which are the unpaired ones? Now from the diagram there, I can see we have the unpaired. Let's start with the unpaired. At the top, we have what we call the dorsal fin. The dorsal side of an animal is the back side. Your back is the dorsal. Your front is the ventral. Okay, the front or the belly side is the ventral. And therefore, we have the dorsal at the back. Then we have the tail fin, whose name is called the caudal. Then we have another unpaired, which is the anal. You can see where the anal is, and the word anal is because of this position very close to the anus. Those are the unpaired, meaning it's just one dorsal fin, one caudal, and one anal fin. Then we have the paired fins, and telling them by their name is very easy because we have the pectoral and the pelvic. If we had done the bones, the skeleton, the human skeleton, you know that our shoulder, where your arm connects to the trunk, to the body trunk, we call it the pectoral girdle, where I don't know, we call it the scapula. Okay, so equivalent to the hands on the fish, we have the pectoral fin. So it's closer to the opercula. Okay, then below and slightly behind, we have the pectoral fin, which again is equivalent to our legs, and there are two. So the pectoral, there are two, one on the left side, the other one on the right side. Same case with the pelvic. We have two of them, but this one normally they are closer together, but there are two of them, and they're equivalent to the legs. In our body skeleton, where our legs are joined to the backbone, we call it the pelvic girdle, and therefore these ones we call them the pelvic, the fins. So these are the two paired ones, and so when you go to their function, they have slightly different functions. All of them are used, yes, for steering or for movement. But you see, instability of the fish is one, it wants to move forward. We call that one steering. Then we have changing direction. Okay, it can change direction, just like a boat would want to change direction. I'm not very good in moving. I don't know whether we call them the oars. Those two, whatever, muiko, the boats, the una roll so that it can move on one side or straight. See, when you want it to turn on one side, you don't, turn one of the muikos, you turn the one on the left side so that it can move to that side. That is how the fish does. And so it can tell you the paired ones have a slightly different function, okay? Just like a car will apply, a driver will apply brakes, so the fish does that. And so the paired ones, when they're stretched out, they do create resistance and it breaks. So we can go through one by one of these fins, and particularly when you're talking about the fins, you want to talk about the unpaired fins, talk about their functions, and then go to the paired fins and what they do. So I don't know which one you had talked about, Malim, or whether we can go over them again.
You can continue giving them the overview of the fins. We have talked about almost all of them, but you can just talk about them still, so that the guys are able to understand them better.
Okay, I'll start with the fins. Then, of course, maybe I will start. I like starting with the fins. What other structures do we have? I talked about the lateral line. He talked about the inflexible head. There is also the swim bladder. It has a role. Which other structure, guys? Do I even see their names? I have not turned on that. Who do we have in class? Which other structures are involved in movement? Have we mentioned everything? Okay, probably I can talk about that. Mwalimu, you can pick on another structure after me and so forth. So for this one, which one do we start with? Let's start with the unpaired one. We have the tail. Okay, the tail fin, which we said is called the caudal. Now the caudal, if you can check, is the largest. It is the largest. And normally there's something we say is power. Now tail power, if you have looked at the fish, when they want to turn, they can swing the tail so forcefully, making it turn very suddenly. And therefore, this is because it is large and it is long and it has what we call the tail power, which can be calculated. Actually, we calculate it as a percentage by measuring. We measure the length of the fish from the mouth to the tip of the tail, and then we measure the length from the tip of the tail to the anus, where it is, where we have the anal and the anal fin. Then we say the length of the tail, which is all the way to the anal fin, over the total length of the fish times 100. You might find that this percentage can even give you a 40%, very close to 50%. And that is a very high tail power. And it means when the tail power is higher, it can turn the fish, it can, propel it with great force. That is one adaptation. So when we're talking of the tail, we talk of it as caudal tail that is long. Remember, we said adaptation, you name and you describe. So it is long, and this is to enhance forward movement or to enhance propulsion. It also fish to push forward, to create that thrust or force to push forward by creating enough force, since it has a great power, tail power. Okay, so when you talk about that, how many points can you, for example, get from there? Naming the tail and describing it, and what are the functions. For each function, you can get a point or at least 2 points. Okay, then maybe you can go to the other fins. And the fish, we are saying it uses the fins to control the position of the body in the water. The position, is it moving to the right, to the left, or just is it still, is it moving forward? Now, outside of the paired fins, which you said are the pelvic and the pectoral fins. We say the pelvic are equivalent to our legs and the pectoral equivalent to our hands. Now, what are the functions of these paired fins? They have the same function. Number one, balancing. For it to balance, not to fall. You can imagine even for the swimmers, when you're in the water, you can stand still, yet you're not stepping on the ground. Why? Because you're using your hands, you're using your legs to balance. The same way the fish uses the paired fin. They can also use them for braking. And braking, we said, is when it is moving at a speed, it wants to slow down. Or suddenly it has seen something in front. Maybe it's swimming and sees this a shark. It can't just swim into a shark's mouth. It has to brake and maybe change direction. Then changing direction is also a function of the paired fin. So those are the three very general roles: changing direction, controlling pitching, which somebody described very well. Pitching, tendency of it to dive downwards. So those are the four. And so when you're making your notes, make it very brief, and probably you can go defining or explaining how do they achieve each one of these. Now, number one, for example, when the paired fins lie flat on the body, because they can press them against the body, they're not spread out. When they lie flat on the body, it reduces resistance and the fish can move forward. So this time it is using the unpaired fins to propel itself, while the paired ones are against the body to reduce the resistance to movement. Then to change the direction, the fins spread out, but not both of them, because they're on either side. One of them, one fin can be at 90%, no, rather not percent, 90 degrees to the body. Okay, the 90%, how it is like. So it is spread out so that there's a 90 degrees to the body, creating resistance, and the fish turns in the same direction. So you can imagine one hand, like you're putting one hand straight downwards, and you spread out the other one, and you are moving. This is now the fish in water. It will turn into the direction of that hand, which is spread out. And therefore, to break, meaning to stop, it has to spread out both of them. Both fins are spread out at 90%, and that creates resistance and it breaks or reduces the speed. So that's the paired ones. Let's talk about the unpaired fins. We say these are the dorsal at the back, ventral down there, and caudal, which is the tail. The three of them, again, they have common function. One is to prevent the fish from rolling. And rolling, we said, is the tendency of, rotating on its own axis. Is like it's falling sideways and sideways. So that is rolling. And yawing. Yawing is deflection from a course of movement. Maybe it was to move straight, it deflects on the right, on the left. That is yawing. If the yawing is so much, then it means it cannot make much progress moving forward. Okay, so the unpaired fins are used to prevent rolling, yawing, and apart from that, they also contribute to movement. Now, caudal fin on the other side, we said it is large, it is wide, it is long, and therefore it has the tail power. And when it rushes side to side, it displaces a lot of water because of the large surface area, and hence causing forward movement, and can also control the direction of the fish or steers the fish. I mean, that's about what we can talk about the fins. Now, probably, Mwalim, you can help me identify somebody and tell us what is the, what do you call it, the bladder? We call it what bladder?
Swim bladder.
Yeah, and what the bladder is used for in how it is used in movement in water. It has a swim bladder. So what is a swim bladder, or does it contain? Because we know we have urinary bladder with the, what does it contain, and how is it involved in movement? Let's have the input. Molim can help me just identify somebody to.
I have what is Luciano Masinde.
They can raise their hand.
Is Luciano in the class? If it's not there, somebody can raise up the hand and tell us. I think we talked about the lateral, the swim bladder. Someone can raise up the hand and tell us something about the swim bladder. How does it enhance? How does it work in fish? Malcolm Washira.
It provides the fish with buoyancy and enables it to adjust its position, its vertical position in relation to depth in water.
What does it contain, and how does it?
I think it's filled with air.
Okay, that's a good one. There are people here who want to give some input. Somebody, it's important that you describe how does that air enable it to change its position in water. I think that's what Madam was asking you.
Okay.
Levins.
The swim bladder will contain air, and the air content can be adjusted in that whenever the fish needs to swim close to the surface of the water, it will take air into the swim bladder. Now this air will make it less dense, hence buoyant. Yeah, and if it needs to swim deep, it takes in less air, and then it becomes dense, and then now it floats now near the bed of the sea.
Okay, that's very nice, Levins. Emmanuel Kisa. Emmanuel, you have something. Emmanuel, I think Emmanuel, if you don't have something, you can put down your hand. Okay. Madam. Hello, Emmanuel. I think we cannot get you clearly, Emmanuel. You're not able to get.
He's having connection issues.
Yes, I think so. Madam Ndiho. Hello, Madam. I think Madam also had an issue. I think she left the class. I think Madam has highlighted a lot of things about fish and on the swim bladder, and I think Levins has told us, which is very true, that after identifying that we have a swim bladder, now how does it carry out the function of changing the position of the fish in water? And we have talked about it being filled with air. Air makes it less dense or light, and so it's able to swim close to the surface of the water. And when it wants to swim deep, especially times of winter, the times of winter when the surface of the water is covered with ice, so fish will want to go deeper. During winter, the deeper the fish swims, the warmer the water is, so it will deflate the air. It becomes heavier or more dense, so it's able to swim deeper in the water where there's more warmth and where there's no ice. I have seen a hand from somebody. Bonfine, Odhiambo. Madam, you left.
No, I've just come back. It had refused to reconnect. I had to move out and back, so I'm back.
Okay. Yes.
Yes.
There's a student who was talking.
Can you be asked? Can you be asked to describe how the swim bladder how the fish gets this air into the swim bladder?
That one, I don't think so. I really don't think so. In fact, my question is, I don't have an answer to this question, and I'm happy you didn't ask that. How does it adjust or like increase the amount of air while it is underwater? Or does it come out, take in more air? That has always been my question, but I don't think you can be asked that. But the thing is, you can be asked how it works, yes. Why? Because if we check the last question, the KCSE, where they were to write on the adaptation of fish to movement, there is that, where Molim has just explained, it can alter the volume of air. When it reduces the amount of air, it makes the fish heavier, and therefore it swims deeper in the water. When it increases the amount of air, it becomes lighter and swims, in shallow waters or up near the surface. So that is all that you're about. You can be asked how it works. And actually, if you're describing how it enables you to move or whatever, you must know that one.
Okay.
So Mwalim, I'm looking at a question here. I don't know whether I can be able to share. That is the practical of 2011.
I have it.
Oh.
So let me share it with you. I think it is here.
Okay.
I hope it can be
yes,
seen.
That question, so that they can see what is possible to be asked.
Let me
just share
that. Yeah.
Yes. Very nice. Even yours has the answer exactly. And I'll be reading the other questions. This is the fish, and the question was below. Okay, I'm reading from mine. Below is a diagram or a photograph of a fish. Examine it and answer the questions that follow. Now, can you see their labels there? The label up there. Let me see where they. My co-host, can I use a pointer?
Yes, I've made you a co-host.
There is K. I hope we can see the K.
Madam.
Okay. Okay, I will. Now, there is the labels. There's K, there's L, there's M, there's N, there's P, and there's a pair of scissors there. Now, anytime you see a pair of scissors, you know there'll be a calculation somewhere. And so the question one is, name the parts labeled K, L, M, and N, 4 marks. Can you imagine for 4 marks? Just naming. And so you find students confuse the names of all these, but I gave you something that will enable you to know which is which is the dorsal side of the fish, which is the ventral side, which is the pelvic, which is the the pectoral. I know the answers are there. We should have removed the answers. Going all the way, it's going all the way down there is the pectoral, which we said is next to the operculum is like the hand. Then N, I'll just keep, is like the leg, and therefore it is the pelvic fin. Now, the mistake people make here is putting the words in plurals. The arrow is pointing to one of the fin, and therefore you just say pelvic fins, pectoral fins. The other mistake is just writing the word fin without identifying which one. Okay, so it should be in singular.
Hello, Madam, are you still there? Madam Ndiho?
You do with my,
Madam,
yes?
you disappeared at some point when you just used the
Yes,
name
yes,
and
yes.
disappeared.
Oh my, sorry. Yeah, it's shaky. Can you take?
Now, I think Madam's network is not very stable. So we will proceed. She was asking you a question about how the fish is able to inflate it is swim bladder, and you should think about that. Most fish that move close to the surface of the water, they will get the air from the atmosphere. They will grasp the air from the atmosphere. But now some fish will inflate their swim bladder by a mechanism from their circulatory system. Now, this is the assignment. Can you go and find out how fish is able to inflate its swim bladder from the circulatory system? So because there's a connection between the circulatory system and some glands that secrete oxygen from the air that has been taken into their bloodstream. How does that happen? What are those glands? And how is that connected all the way to the swim bladder? So now to this question, sorry, I had forgotten and put the question with the answers, which you should not, should not have. But then the students were asked first to name the parts K, L, M, N, and P. And I had Madam tell you that one is you should be able to identify, as you identify the parts, the sides of the fish, you should be able to know the dorsal side and the ventral side of the fish. And the dorsal side is the upper side, the ventral part is on the lower side. Now, naming the parts. I don't know if, Madam, you can project the question without answers. Madam, are you there? So that we can now discuss it without answers. So that people are able to think. Madam, are you there? Hello?
Hello.
Hello? Okay, so we can still proceed. So, from now the problem is that I put answer and that one makes it difficult to tell you to name the parts. But part K is the pectoral fin. L is the dorsal fin. Pectoral fins, as we said before, they're paired fins. And L, dorsal fin, is an unpaired fin. Unpaired fins prevent the fish from two anomalies that can take place during movement. That's rolling and yawing. Then we have the anal fin. Actually, the anal fin can, in most fish, the anal fin is so tall, it's almost half the length of the whole fish, whichever size of fish that you have. The anal fin is always almost a half of its length because it is the one that provides the propulsion force. And then N is the pelvic fin. Now that tells you that besides being asked to describe how the fish is able to move in water, besides being asked to describe the adaptation of the fish to its functions, you can be asked on a practical question to name the parts of the fish. And then a structure P can be extracted. Structure P can be extracted from the fish. I don't know. Yes, we'll come to it. And then you can be asked a lot of questions from it. So, for example, in 2011, when structure P was extracted, I want you to look at the diagram there of structure P, and the contents inside it. And the students were they were given the photograph. Let me move this thing somewhere here. So the photograph below shows structures visible after the removal of the pass label P. The instead is a magnified view of the structure. That's what Madam said when she was introducing that as much as in Form 4, we put a lot of emphasis on structures that enable the fish to move in water. You should not forget the Form 2 work that you learned about gaseous exchange in fish. In fish. Sorry. Now, so now the question was, name the parts labeled R, S, and T. And unfortunately, I don't know, Madam Ndiho, are you there? I want, I think, Madam, I wanted an image that has no answers like mine. But that was that they were expected to name the parts R, S, and T. And so, Jonathan,
yes,
you want to answer for us?
I want to ask if the anal fin is also referred to as the ventral fin.
Is the anal fin also referred to as the ventral fin? Somebody to answer from the class. Answer from the class.
Yes.
Yes.
Okay. Are we okay now?
Yes.
Because we have learned those before, yes. So R, S, and T in that order: gill breaker, gill bar, and the gill filaments. And another question you can be asked here is to explain how each of the parts above is adapted to its functions. So that one, I want to get it from you. I want to ask the adaptation of the parts first, and then from there, you will also tell me, I will also ask you a different way in which that question can be asked. So how is the gill bar, the gill breakers, and the gill filaments adapted to their functions? Somebody? How are they adapted to their functions? Yes. What is the adaptation of the structures, the gill bar, the gill breakers, and the gill filaments to their functions? Somebody? Hey, I want to see hands in. I know hands still. Wakaihu, you have something to say? Guys, I've gone silent. I've gone mute. Jonathan.
The gill filaments are long and numerous to increase surface area for diffusion of respiratory gases.
So the gill filaments, you have said that. So you have talked about two things. You've talked about long and numerous. So those are two different adaptations. So so is it? Of course, both of them increase surface area for gaseous exchange, but they can be different adaptations. Okay. So
yes.
The numerous can stand its own long, both increase surface area for gaseous exchange. Ni sawa? Another one. Another one. Yes, Levins. I'm seeing a lot of Levins and Bonfim, and but other people are silent. Levins.
Yes.
Mm-hmm.
The gill filament has a thin epithelium to reduce the surface area for. I mean to reduce the surface area at which the respiratory gases diffuse. Hence, yeah, and making sure that there is fast diffusion.
They have a thin epithelial layer, or they have a thin layer of the epithelium to reduce the diffusion distance. Okay, the distance through which the respiratory gases diffuse. And when we're talking about diffusion in Form 1, in cell physiology, you say that the distance, if in case the epithelium is thick, then it will take a long time for the gases to diffuse. If it is thin, it reduces the diffusion distance. Omutere.
The gilba, they are long curved and bony structures which they form site for attachment of the gill filaments and also the gill rakers.
So the gilba are bony, they're bony structures. Put together, they're bony structures. And that being bony means that they're hard, and so they offer support to the gill rakers and the gill filaments. Somebody has not told me about this, anything about the gill rakers. Bonfim.
Not about the gill rakers, but the gill filaments. The gill filaments are highly vascularized to provide a steep concentration gradient, hence increase the rate of diffusion of respiratory gases.
They're highly vascularized. They have a large number of blood capillaries. And this one is to, number one, to increase the concentration, to raise the concentration gradient, to make it so steep. And the steeper the concentration gradient, the higher the rate of diffusion. That's what we talked about. Concentration gradient is the difference in concentration, that one side has more oxygen, the other one has less. So when the blood capillaries are continuously transporting the respiratory gases away from the filaments where gaseous exchange takes place, there's always a steep concentration gradient, which enhances fast rate of diffusion. Somebody talk about the gill rakers. Bonfim.
The gill rakers are sharp and pointed to trap solid particles, hence protecting the.
We always talk about the adaptation as being teeth-like structures. They are teeth-like structures. Together, which are pointed. Are you together? And that one enables them to trap solid particles and prevents them from reaching the gill filaments. Okay. Now, you can be asked that question in a different way. So, for example, you can be asked to describe how the gill filaments are structurally adapted to their functions. How will you answer that question? How are the gill filaments structurally adapted to their functions? Yes. Yes, Bonfim.
I think to answer that question, you look at how the shape and how it is. I mean, how it's shaped. For example, it is long. There are numerous and thin epithelial and vascular.
Yes. You talk about two aspects. Talk about the vascularization. What they contain, what they have that enables them to carry out gaseous exchange. So we talk about them being highly vascularized, and then besides that, you also talk about the thin epithelium, but you don't in the structural adaptation you don't talk about them being numerous. So you don't talk about them being numerous. You talk about them being highly vascularized, and then you also talk about them having a thin epithelium. Malcolm?
I think my question is on, there's also a structural adaptation on the gill filaments having I think, lamellae. Could you explain how those lamellae help in the adaptation?
The blood network of the capillaries, okay, or of the gill filaments, right, together. And the whole essence is to enhance diffusion of gases. So as you know, the water passes through the lamellae, have some channels through which water that is rich in oxygen passes through. As water passes through, the respiratory gases diffuse. Oxygen diffuses into the bloodstream, and carbon dioxide diffuses out. Right, together. So they innervate. They pass next to the blood capillaries. Right, together. They act as water channels or chambers, close the blood capillaries, and that one enhances faster diffusion of the gases. Okay. Are we there, Malcolm? Yes, lamella are just channels that are close the blood capillaries, and they enhance diffusion because water passes through the channels, and that one enhances diffusion. Omutere.
My question is, Madame talked about the tail power. So my question is, apart from the two lengths, are there any other physical factors which affect the tail power of a fish?
Apart from which aspects?
The two lengths.
The length of how do you calculate the tail power? By measuring the distance from the tip of the mouth to the tip of the tail, right, together, and then the distance from the anal, from where the anus is, the tip of the tail, right, together. So you divide by the distance from the tip, the anus to the tip of the tail, divide by distance from the tip of the head, the tip of the tail, times 100. So you're asking, is there any what? I've not got your question well.
Is there any other physical factor which affects the tail power?
Any other physical factor that affects the tail power? I'm not very sure if there are any other physical factors, but you can find more out more about them. So I don't have an exact answer to your question, but you can find more about that. So Levins.
Excuse me, sir. I've lost with how you have said we should say that one for gill rakers.
About
the gill rakers, how its adaptation is represented.
Oh, I said the gill rakers are teeth-like structures, right, together, which are pointed, and the essence is to trap solid particles and prevent them from reaching the gill filaments. Okay, so because if the solid particles like the soil reach the gill filament, they will cover the surface of the gill filaments and prevent gaseous section from taking place. So they will clog the filaments. Are we there, Levins? Okay. So I want us to move forward. So you can be asked the question on, you say the adaptations, or you can be asked about the structural adaptations. You should be able to know. You eliminate the numerous nature, and then you can also be asked to describe how the gills of our fish are adapted to gaseous exchange. The gills of our fish, and so you can describe it in two aspects. You can talk about the three parts: the gill bar, the gill rakers, and the gill filaments, or you give three adaptations of filaments and still score. You can talk about the teeth-like structure of the gill rakers. You can talk about the gill bar being hard, bony. That one makes that for support. Talk about one adaptation of the gill filaments. You will score 3 marks. Or you can talk about the thin epithelium in the gill filaments. You talk about the numerous gill filaments, or you talk about the vascularization of the gill filaments and score all the marks there. So it will depend on how you will approach it. We come back to our support structure here. The next thing the students were asked is to calculate the actual length of the pair of a pair of scissors was given there, and it was given to have a length of 12.5 centimeter. Now you use the information to calculate the actual length of the fish. How do you go about that? How do you go about that? How do you get the length of the fish? You've been given the actual length of the fish, and then the fish has been given to you with given dimensions, having the drawing length. Okay, so how do you calculate now the actual length of the fish? Somebody give us an explanation. Wakayu, you should be mute. Wakayu. Yes, Clifford.
We have been given the actual length of the scissors, and using the diagram that we have been given, we should determine the drawing length of the scissors, and after finding the drawing length, we use it together with the actual length to find the magnification that is being used in the diagram. Then next, we determine the drawing length of the fish itself. Then we use it with the magnification that we had already found using the scissors to determine the actual length.
Okay, so number one, we have been given the actual length of the scissors. So the next thing you do is to measure the length of the scissors that you've been given in your paper, and then you find the drawing length. How do you get magnification? Magnification is the linear dimension of the drawing divided by the actual length of the object. So if you are to measure, if you are that student, if you measure the length of the scissors, it will be it was around 3.5 centimeters. You divide by the actual length, which was 12.5, then you get a magnification of times 3. And when you're writing the magnification, the X must be in capital. It should be with the same size as the figures, as the numbers you've written there. Okay, it should not be small size, it should be times 0.3. That's the magnification. So how do you get the actual length of the fish? Length is the linear dimension of the drawing divided by the magnification, and then you get the actual length of the fish. So first you have to get the magnification, and then next you use the magnification to get the actual length of the fish. So the scissor was to give you a leeway how to get the magnification, and then you calculate the actual length of the fish from there. That was how. So then the other question, name the fins that prevent the following movements in fish during swimming. Yawing. Which fin prevents yawing in fish? Yawing. We talked about yawing. Which fin prevents yawing in fish? Somebody?
Dorsal.
Yes, Frederick.
Dorsal and anal.
Good.
The dorsal fin and the anal fin. Pitching in fish. Pitching.
The paired fins, pectoral and pelvic.
Good. So that was the practical that was set. Our point is in this question is that as you look at fish, we have discussed about how the fish moves in water and what it has that enables to move in water, from the fin, the part of the body, and all those things. You should never forget other things that you've learned before about fish, especially on aspects of gaseous exchange, which you learned in Form 2. So it can be set in all those dimensions. So you can get a question on fish in an essay question. You can get it also in the practical question, besides getting it as a diagram in any other questions, either in paper 1 or paper 2. So next we should be moving to support and movement in mammals. And when we move to support and movement, yes, Levins.
I'm sorry to return us.
Yes.
About the structural.
I'm not able to get you clearly.
We were talking about the structural adaptation of the gill filament, and I think we say that it being long is not a structural adaptation, isn't it?
No, I talked about numerous. Them being numerous, the gill filament being numerous. Just come up with your answer and your question. Your question. I interrupted you. Continue.
Yeah, I thought that we said that it being long. I thought that it is.
So leaving some note. I've not got you well. Maybe you can type your question.
Okay.
So I've not really got you well. So we proceed. I think we have done much on fish. We have done much on fish. Just give me just a minute. Just a minute. I sort out something and then I'm back. Is Madam Ndiho here? She can proceed as I check on something. Okay, we are here. Now, I just want to introduce a small bit of this question, of this topic, and then we see this part, and then we finish the lesson. Yeah? What's happened are movement in animals, and this will cover most of what we learn in in this topic. So here we're going to talk about bones and muscles, and we will also talk about cartilages. But we will base our discussion much on bones and muscles and joints. So before you is the structure of the skeleton. If we talk about the skeleton, first we talk about the cranium, which is the head. Then they will talk about the role it plays, the various parts of the cranium that play specific roles. We'll talk about the vertebral column, which is we call the backbone. We'll talk about the ribs, the rib cage, and this bone here called the sternum. We'll talk about the limbs, which are the hands and the legs, and the various bones that attach them to the rest of the body, which, as Madam told you earlier, when you're talking about fish, talk about the pelvic bone and the pelvic fin, which we'll talk about the pelvic girdle. And then on the lower side, we have the pelvic girdle, and then we have the pectoral girdle, which is close to the arms here. The pelvic is down here that attaches the limbs on the lower side to the rest of the body. So, and then we also talk about the other bones that are attached to the various parts of the body. So majorly we talk about the axioskeleton and the appendicular skeleton. In the axioskeleton, we'll talk about the skull and the vertebral column. And then we'll also talk about the rib cage and the sternum. In the appendicular skeleton, we talk about the limbs and the bones that attach them to the body. The limbs of the hand, that's the hands and the legs, and the bones that attach them to the rest of the body. So as you study along, know that this is what you're going to study and prepare adequately for the next lesson. So know the skull and the adaptations, how it's adapted to its functions, sternum and how it's adapted to its functions, the rib and how it's adapted to its functions, and then the rest of the bones of the vertebral column and how they're adapted to the functions. So each and every bone you learn the parts and the adaptation to their functions. I think we can stop from there today. I wish you well and have a nice day. Thank you.
Thank you, sir.
Thank you, sir, and have a nice day.
Thank you, sir.
Thank you, sir.
Nice time, sir.
Thank you, sir. Thank you, sir. Thank you, sir.
Yes.
Thank you.